Hello everyone. I hope my voice is clear now. We have started the session officially. Let's just wait for 5 more minutes before we get all the people joining up with today's session. Thank you so much for joining in. If you have got any of your friend who is interested to join today's session, just drop them a link, the live link of today's session, and make them also participate in today's session. We will be starting the session sharp at 8 p.m. So it's 1957. If you have any of your friend who has not joined the session yet but has registered for this particular program, ask them to join now. Thank you so much guys for joining in. Thank you so much for joining in. If you have not subscribed this YouTube channel up till now, just do it. We will be coming up with many short videos and we will be coming up with the complete playlist teaching you about the fundamentals and everything that is associated with the design and development of electric vehicles, automobile, conventional uh, vehicles or automobile. To just come up with the entire content of technology or to understand more about the technological products, technological regime, just follow and subscribe this YouTube channel. Okay, the count reduced. We have got 22 people who are with us now. So just 2 more minutes to go and then we will be officially starting today's session. Good evening, Saurabh. Good evening, J Nation. Good evening, Atul. Okay, could you people please confirm if my voice is clear? Could you people please confirm if my voice is clear? Atul, I have just seen it. Let me just check. Hello. Okay, Saurabh, Somali, Manoj, Soumyadeep, thank you so much. Atul, I believe this is the error from your side. Okay, so this is 8 p.m. sharp, and now I believe this is the time for us to start the session. So thank you so much, everyone, for joining up with today's session. Though this session was scheduled to be conducted on 19th of February, that is yesterday at 8 p.m. But due to some unfortunate condition, I was not able to take up the session yesterday, and I have postponed it to today. Learning should never stop. Like if we have committed that we are going to take up this particular session, the date could change, the time could change, but we will be coming up for you people. So thank you so much everyone for keep waiting and joining up with this session today. My name is Abhishek Jain. I'm the founder director of ARC Global. We have been working in the field of student motor sports for the last 8 years, providing trainings, workshops, and everything essential that is required to bring these students out of the confines of the classroom. We particularly believe that engineering is not something that can be done inside the confines of a classroom. And students should have to break free to start solving some real life problems. This effort of ARC Global to come up with such kind of practical oriented workshops is to make people understand, is to make students understand the real regime of engineering, what they can do by implementing the classroom learning. So here in this particular session, we will be discussing about the derivative of your classroom learning programs. I will be telling you the exact way how you can design the electric Baja Buggy. Last week on Monday, that is 12th of February, we came up with the complete session on Baha Buggy design essentials. In that particular session, we discussed about the essentials, the fundamentals that are required to design a Baja Buggy. In this particular session, we will be constraining our entire discussion towards the electrical part of it. So I'm not going to say that we will be just discussing about the electronics or the electrical engineering. Definitely not. We will be discussing about each and everything that is associated with the design and development of a Baja Buggy, but at the electrical end. Okay. So before beginning up with today's session, let me just give you a bit of hint about this particular term Baja Buggy and what this session is all about. If you are a student or you are a part of any student team which is planning to participate in any kind of student motor sports event, yes. So if you are the engineering student or if you are planning to participate, if you are planning to join any engineering institute, you will find out that the engineering institute students have got the opportunity to form a student team and participate in some kind of student motor sports event. So in India, we have got many other kind of student motorsports events. Like you can design and build a go-kart, you can design and build a Formula type prototype, you can design and build an ATV, you can design and build some other kind of vehicles. Now when I say ATV, that is all-terrain vehicle, we call it Baja Buggy. I'm not sure like if the Baja term is originated from Greek or is originated from France or is originated from Italy. I'm not sure about it. It could be, I believe, French or Italian word. But whenever we talk about Baja, Baja means off-roading. Okay, off-roading. And with the buggy, you can say a carrier, something that carries the humans, that carries the cargo, that carries the entire structure of the vehicle. Okay, so we will be discussing about the Baja Buggy, the off-roading kind of vehicle. And when I say off-roading kind of vehicle, I will not be just talking about the professional automobile that you see into the marketplace. I won't be talking about that. I will be specifically constraining my discussion towards the kind of Baja buggies that student teams use to develop. So if you are the Indian student or if you are the international student, we have got some of the Mexico registrations here as well. So when you plan to participate in any kind of student motorsports event and you have been asked to design a Baja buggy at the electric segment, at the combustion segment, there are certain rules and regulations that are needed to be followed. So now kind of a structure that you need to develop, how a vehicle looks like, what engine capacity you can use, what motor power you can use, what kind of tires you can use, what kind of race track you are going to participate in. All these things are very much fixed. Okay, so you can also call it this is special purpose kind of vehicle that the student teams need to develop. But why do they develop this thing? First, in the entire engineering degree program, all these students work on the individualistic activities. So when you go for the examination, what you do? You need to study the entire subject on your own, you need to practice on your own, and then you need to write down your entire exam on your own. But who will teach you about the inclusivity and exclusivity of forming a team? The integrated approach to design and develop a simulated product or the actual product. When you participate in any kind of event, it is not just about winning or losing. It is about developing the approach to really understand how engineering works in the real life scenario. And participating in such kind of event allows the students to feel the inclusivity and diversity of engineering. Okay, so when you think of participating in any such kind of student motorsports event, you form a student team of 25 members, 30 members, or 50 members. When you form a student team, you get to learn how to work within a team. Or if you're a team leader, you get to know how to get the work done by the other team members. You get to understand about the different tempos of different people, making them work together. You have got a constrained timeline of few months, say for example 6 months, 3 months, 4 months, in which you need to develop a real-time product. And when you get to the final event site, everyone is using the same concept of engineering. Everyone is using the same formula to derive the understanding of that particular topic. But when you look up, every team's vehicle is different from other team. Now this will teach you about the innovation, how that particular law of engineering can be implemented in different ways. What mistakes you have committed this year, what mistakes you can avoid in the coming session or in the coming seasons. Right? This is what student motorsports teaches you. Or it's not just about student motorsport, whatever you are interested in, this particular event criteria, event regime teaches you this thing. So if you are an engineering undergraduate, or if you are just an undergraduate with any kind of degree program you are currently enrolled in, I would recommend you people to go out of your campus and look what is happening in the world in the field of your interest. Definitely go learn by implementing that particular fundamental. Okay, so moving forward, I believe you people got the understanding what this entire session is going to be all about. If you do not know what is Baja Buggy, I would recommend you people to go through our previous webinar that we have scheduled, that we have conducted on 12th of February. You can find out that particular webinar in the same YouTube channel. If you have not subscribed us, yes, I would just recommend you people, I would request you people to please subscribe this YouTube channel. This will not just help us growing, but it will also help you in getting better understanding about the technology or about the technological products. So we will be coming up with such kind of sessions every week. And in future, as we are going to get the better response from you people, we will be increasing the frequency of such free videos for you people on YouTube, which will be giving you the clear-cut instructions on how the entire structure, entire vehicle is needed to be formed or is needed to be developed. In future, we will be moving up with Industry 4.0 content, robotics content, IoT content, AI, ML content, and everything that is associated with the technology. Let's move forward. Let me just give you the entire construct of today's session, what this session is all about. So before that, try to understand what is ARC Global. This particular session is brought to you people by ARC Global. ARC Global is the only company of India which provides the complete training solutions in the field of student motorsports, as well as which provides the complete manufacturing solutions. We're the only authentic, reliable source for the student teams. So be it CAD, be it CAE, be it the design and development of a particular vehicle, or be it the internship come training programs on automobile engineering, on electric vehicle design and development, CAD, CAE, we have it all. So if you are a student team thinking to participate in any kind of student motorsports event, if you're planning to build a go-kart, a ATV, a Supra, we have got the complete team mentorship program for the student team. 6 months hand-holding mentorship program, 4 weeks training program, 2 weeks training program, and a single week training program. So if you want to excel in this particular journey of designing and developing a vehicle, I would recommend you people to please drop us a message on our Instagram handle, visit our website, or just drop a text message, a WhatsApp text message on this particular number, 8800219630, and our executives, our team will connect with you to give you the complete details about these sessions. Moving forward. Oh, we have got our Instagram handle, and today we reached 1,000 followers on our Instagram. So thank you so much, everyone. If you have followed us, if you have not followed us, I would request you people to please give us a follow on Instagram handle. We're available on Instagram with the name of ARC Global _ARC Global. You can find us there. This is our official logo. Find us on Instagram, give us a follow. We will be coming up with short reels, and you will get updated with all the upcoming workshop that we will be coming up in future. So thank you so much. Let's move forward. So in today's session, at first we will be discussing about the difference between conventional vehicles and electric vehicles. Conventional vehicles and electric vehicles. So you will be getting to know about the very good insights of how technically you can compare the conventional vehicles, conventional IC engine vehicles, my dear friends, and the electric vehicles. And everything that I will be discussing in today's session is going to have the at-par technical content, which will help you out in having the better understanding of this particular topic. Moreover, will also help you in understanding the engineering process of knowing these vehicles, knowing this particular topic. Then we will be discussing about the different components of electric vehicles. Different components of electric vehicle. After finishing up, now when we say electric vehicle, I will be just discussing about the components that are different from the conventional IC engine based vehicles. And after that, we will be concentrating our discussion towards the electric Baja Buggy. We will try associating our entire discussion with the Baja, or we will definitely associate our entire discussion with the Baja Buggy design and development, where I will be telling you what is needed to be done to increase or enhance the performance of your vehicle, how you do it, and why is that particular step important. So this particular session has been designed in the very chronological and technical way so that you would get to know the entire process of designing the electric Baja Buggy. So thank you so much everyone for joining up with today's session. We have got 52 live viewers for this session. Just stay here, learn something good. As you all know, this is a free certification session. Anytime between the entire conduction of the session, I will be sharing the attendance link with you people. You are required to fill up that particular attendance form within that particular time frame. So once you fill that particular attendance form, I will be like opening up that particular attendance form for 5 minutes. And once you fill it within 1 week time frame, you will be getting the certificate of participation for today's session. So thank you so much everyone for joining up with today's session. Let's move on with the content now. Electric Baja Buggy. Baja means off-road. And when I say it means a carrier. Okay, now electric. You must all know whenever we talk about the automobile or whenever we talk about the vehicle, we have got a power source. When I say power, it means we have got a kind of system that makes our vehicle moving, that allows our vehicle to move. Okay, got it. Okay, so I have designed or I have developed a vehicle and now this vehicle is moving forward. Now, if this vehicle is moving forward, there must be a kind of mechanism that is allowing my tires to rotate. What this mechanism is, I will be using the IC engine or I will be using the electric motors to rotate my tires. Now, when my tires are rotating, I have discussed about this thing in the previous session, that your engine or your motor has only got the responsibility to rotate your tire, but it does not have the responsibility to move your vehicle forward. But how does your vehicle move forward? It moves forward because of the traction availability between the tire and the road. Your vehicle moves forward. See, your engine, your motor has only got the responsibility to rotate the tire, but your vehicle is moving forward because of the relationship between the tire and this particular road. And this particular relationship between the tire and the road is regarded as the traction availability, or the traction is regarded as the traction. Please make sure of this one particular term, my dear friends. It is regarded as traction. So I won't be discussing about traction as of now. I will be just limiting my discussions towards the electric vehicle. And even if you've got no experience of knowing what electrical vehicle is, you will be getting to know about each and everything associated with it. Just stay with me. Trust me. So thank you so much everyone. We have got 59 live viewers. If you have got any of your friend or if you are a student team planning to build the electric vehicle or have already built the electric vehicle, I would recommend each one of you to please ask all your friends to join this particular live session. They will be getting to know about the fundamentals which they have never thought of. No, I won't like say I won't guarantee this thing. I know you all are very smart people. You know each of these things, but maybe with the kind of a system that I am providing, maybe you would be getting a quick revision of all the concepts that you already know. Let's move forward. So we know this thing that this particular power source, whenever we talk about the electric vehicle, is the electric motor. Is the electric motor. Now in the conventional IC engine vehicles, we have got the IC engine, the internal combustion engine. But how the entire mechanism of driving the vehicle forward is different in the case of electric vehicles and in the case of IC engine based vehicle, internal combustion engine based vehicles. So let's just try to understand this thing. First, which vehicle is better? Electric vehicle, EV, or the combustion engine vehicle? Which vehicle is better? Undoubtedly, if I need to talk about this particular difference, I would say electric vehicle is much better in comparison to combustion vehicles. But you will find out we have all got the habit of driving the combustion vehicles. And since our childhood, we have got this preconception that whenever we talk about the vehicle, whenever we talk about the motorsports, whenever we talk about the automobile, it's just all about the IC engine. It's all about the petrol vehicles, diesel vehicles, CNG vehicles. We have got no idea how does the electric vehicles usually work, or even if we find out the difference, or even when we look up into both of these vehicles, we always try to pick the combustion vehicle at first, right? Because this is the preconception that we have got in mind. But look up into the factors like efficiency, look up into the factors like effectiveness, look up into the factors like sustainability. In every sense, you will find your electric vehicles are far better in comparison to combustion vehicles. But why does this industry entirely dependent on the combustion engine for all these years? This is a completely different topic. We will be coming up with this particular kind of session in some other day. So we won't be discussing about this thing, but I want you people to please think about it. Search it on internet. Okay, why it took more than hundreds of years to diverse the entire industry, deviate the entire industry from combustion engine to electric vehicles. You will also be surprised to know that the electric vehicles have already been developed about 100 or 150 years ago. But nobody has thought of coming up with the mass production of electric vehicles. There are certain reasons, certain technical reasons, certain political reasons which people often talk about, controversial reasons. But I would say there are many technical reasons. Okay, why the electric vehicle never got popular at that particular time. And why is it getting popular nowadays? So we won't be discussing about it. We will be discussing about this particular thing in a later segment. Now, whenever we talk about the IC engines, this is a common process. We have got a cylinder. We have got a combustion cylinder, or we call it the combustion chamber. Now, inside this combustion cylinder or combustion chamber, we have got the fuel. We have got the fuel, which is mixed with air. Okay, now if it is a petrol vehicle, we have got the air and the fuel mixed by the help of carburetor getting inside it. If we have got the diesel engine, if you've got the amplify engine, both are going to be mixed inside the cylinder, whatever it is. Okay, let's not talk about it as of now. So we have got the air and the fuel mixed. Okay, now fuel and air acts at the medium where the fuel is going to burn. Okay, fuel requires the medium to burn. You cannot burn the fuel in vacuum. Okay, it requires the medium to burn. So when you are going to pressurize it, this particular fuel is going to self-ignite, or I will say, when you pressurize it with a certain or with a small bit of fire, or you can say a spark, it ignites. So at a very high pressure, when you ignite this particular mixture of fuel and air, when you ignite the mixture of fuel and air, what happens? See, I've got the air, I've got the fuel at a very high pressure. I've ignited it. So as soon as I ignited it, the chemical energy of this particular mixture, particularly the chemical energy of this fuel, converts into kinetic energy. It starts to convert into kinetic energy. Now, please make sure of this one thing. What actually happens, how does it convert into kinetic energy? We will be discussing about this particular thing. It converts into kinetic energy, and then we will be having certain fumes coming out, certain impurities, pollutants coming out. Okay, that's a different scenario. We won't be discussing about that particular thing in here. But this is how the entire thing works. So I have got this particular fuel. I mix it with the air. I compressed it and I ignited it, and it happened. Or sometimes you do not even require the ignition, you do not even require the spark. It auto ignites. In the case of diesel engines, it auto ignites. Okay, you just press it. After reaching a certain pressure point, after achieving a certain pressure, your fuels burns on itself. Okay, burns by itself. Okay, when it burns, the chemical energy of this fuel starts converting into kinetic energy. Now let's see. If I talk about me, if I talk about you, if I talk about anything in this world that has got a mass, if I talk about anything in this world that has got a mass, you will find out every mass is made up of the bundles of energy. So if someone asks you what is the most primary source of life, or if someone says anything in this world that exists, what is the most foundational unit of developing any particular thing? So you would be saying it is atom, cells, electrons, neutrons, plasma, whatever you want to say, that's fine. But even if I say atom, how does atom form? So you can say the basic unit of existence is energy. Basic unit of existence is energy. When bundles of energy are aligned together in a certain form, they form are aligned in a certain form. They create either, so you can say it creates some mass of different kinds. Okay, of different kinds. You can call it the liquid, you can call it the solid. In solid, you can call it the XYZ type of solid, ABC type of solid, EFG type of solid, whatever you want to call it, you can call it simply, right? I hope I am clear now. I'm clear here. So we know this thing that the basic unit of anything that exists is the mass, or you can say is the energy. So better to say basic unit of existence is energy. So even when I talk about fuel, what are fuel? Anything out of which we can derive the energy easily. Okay, anything out of which energy can be derived easily. Easily means with the practical approach, the energy can be derived. Okay, with which you can derive the energy. Simple. Okay, so for example, for us, the fuel is petrol, diesel, kerosene. These are the fuels, LPG, CNG. These are the fuels with certain criteria, certain instruments, with the certain system, we can derive the energy. But if I give you uranium, can you derive the energy out of? No. But for some time, scientists, for some labs, it is the fuel, right? If I give you my body, can you call it the fuel? No, because you won't derive the energy out of it, right? You won't call it. So anything with which we can derive the energy by combustion, we generally call it the fuel. So if I say petrol, diesel, or the petroleum products are the fuel, petrol is the fuel. So I can say 1 kg of petrol. If I've got 1 kg of petrol, I can definitely say 1 kg of petrol contains certain energy. Contains certain energy. Okay, so 1 kg of petrol is equivalent to XYZ count of energy. Okay, how do you calculate energy? You calculate energy in the form of joules, in with the unit of joules. Okay, and now if I say my body fat, if I talk about such things chemically, when we talk about energy in the form of chemicals, we usually calculate it in the form of calories. How much food are you eating? This is the calorific value of the food that you are eating. This is the calories intake that you need to have every day. This is much calorie I used to burn every day when I go to gym. This is how usually we talk, usually we interact. So similarly, I can say 1 kg of petrol will be having certain calorific value. Identified calorific value, how much is it? So I can say 1 kg of petrol has 45,000 megajoules of energy. Could you please check this data? Is it 45,000 or it is just 45 megajoule? Is it 45,000 or is it just 45 megajoule? Could you please check? Yes, everyone. Could you please check? Is it 45,000 megajoule? So it is not 1 kg actually, it is 1 liter, but just for the sake of calculation ease, I have just written it. 1 liter of petrol means somewhat around 800 gram of water. Okay. Okay. So 1 liter of petrol is somewhat around 42 to 46, or you can say 45,000 megajoule of energy. So we all know this thing very clearly. Okay. I'm really sorry. It is not 45,000 megajoule. Sorry. Kilojoule. I'm really sorry. 45,000 kilojoule of energy. 45,000 kilojoule of energy. So I can also say if I burn 1 liter of petrol, I would be able to generate 45,000 kilojoule of energy. Or I can also say if I burn, okay, say 1 ml of petrol, I can generate 45 kilojoule of energy. So just to give you the better understanding between the difference between electric vehicles and petrol vehicles, let me just do this calculation for you people. Say for example, you have Alto at your home. The average is 20 kilometer per liter. Have you ever thought how much petrol? Have you ever thought how much petrol how much petrol does your vehicle consume for 1 liter? Sorry, for 1 kilometer movement? We all know this thing. But have you ever thought how much energy is your vehicle taking up to move the vehicle for move the vehicle 1 kilometer at a certain velocity? So you would say, if I move my vehicle at a speed of 60 kmph or 70 kmph, I usually get the 20 kilometer of average, 20 kilometer of mileage. So 1 liter of petrol gives you 20 kilometer of range. So for 1 kilometer of range, how much petrol are you consuming? For 1 kilometer, so 1000 megajoule, milliliter, sorry, divided by 20. So 50 milliliter of petrol is equal to 1 kilometer. My dear friends, please look it very clearly here. To move the vehicle for 1 kilometer, how much petrol does your vehicle consume? 50 milliliter. 50 milliliter. Sorry, I've just told you to move your vehicle for 1 kilometer, you require 50 milliliter of petrol. I've also told you that 1 milliliter of petrol is equal to 45,000 joules of energy. 45,000 joules of energy. I have just told you this one particular thing. So 50 millijoule, 50 milliliter of petrol is equivalent to 225 triple zero of energy. Okay, 22 lakhs 50,000, or I can say 2250 kilojoule of energy. Okay, 50 milliliter. It means to move the vehicle by 1 kilometer, to move the vehicle by 1 kilometer, you need to consume, your vehicle consumes 2250 kilojoule of energy. Please remember this one thing I am saying. To move the vehicle for 1 kilometer, 2250 kilojoule of energy is consumed by the vehicle. Okay, usually whenever we talk about this particular thing, we don't measure it in the form of energy, we measure it in the form of power, in the form of power. So my dear friends, please remember this one particular thing. The most fundamental basic unit of existence is energy, is energy. But it is literally impossible for you to measure the count of energy. To measure the count of energy, we have got an instrumentation setup. We have got certain indicators. And these indicators, in this list of indicators, the very first indicator is power. Okay, so the most basic unit of existence is energy. After that, we got the power. The rate of conversion of energy. Energy can neither be created nor be destroyed, verified. It can be converted from one form to other form. But to convert the energy from the chemical form to the mechanical form, see, I am converting the chemical energy into kinetic energy. So we know this thing whenever we do this thing, and when we talk about the space, we know this thing, time is the most important dimension. Space, time, these are the most important dimensions. Okay, if the entire world is needed to be configured in the form of dimension, you would say space is one dimension, time is one dimension. So time is there, right? So what is actually happening? Time. It will take certain time to convert this chemical energy into kinetic energy. Okay, so it means 2250 kilojoule of energy is going to be converted into some other form. Chemical energy is going to be converted into some other form, that is the kinetic energy, in certain time frame. That is 1 second, that is 2 seconds. It means the rate of conversion of energy, rate of conversion of energy is equal to power. Okay, so delta E by delta T is equal to power. And whenever this conversion occurs, I have just told you one thing. First dimension is space. Okay, x y z direction, you already know this thing. And the fourth dimension that we talk about is the time. This is as per our understanding, this is as per my understanding. So what is actually happening? See, space, whatever the derivative that we will be getting, it in the form of space and time. Space and time. Okay, this is how it will be happening. Energy is getting converted. So whenever energy is getting converted, you can also call it force into velocity. You can call it torque into rotational speed, whatever you want to call it. So this is how the impact that it created on space. You change your position. You changed your position, and how you change it, how fast you change it is the velocity, space and time constraint. I applied the force. Whenever I apply the force, it is compulsory to have certain change in position. So the position is changing, you can say, and how I say it through the space dimension, and how it changed, how quickly it changed is the velocity. Okay, is the velocity. So I know this thing. If you need to calculate the energy, my dear friends, you cannot calculate the energy if you do not know about the power. And to know the power, you can easily indicate it with the form of force and velocity. Force and velocity. So I know that 2250 milliliter of petrol is burnt. Sorry, I'm really sorry, not 50 milliliter of petrol is burnt to create 2250 joule. In the previous slide, yes. Mm, 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 mm. 2250 kilojoule of petrol is burnt, 50 ml of petrol is burnt to move the vehicle by 1 kilometer. Now I said that the average of my Alto is 20 kilometer per liter if I am moving my vehicle at 60 kmph, or I can say 16.67 meter per second. Okay, or I can also say, if I can also say that in 1 minute, in 60 minutes, I am moving 60 kilometer. Okay, 60 minutes I am moving 60 kilometer. So for 1 kilometer I will be completing it in 1 minute, or I can also say in 60 seconds. So if 50 milliliter petrol is burned to create 2250 kilojoule of energy, it is burnt in how much time? In 60 seconds. So can you please calculate the power? You can say, yes, I can calculate the power. It is equal to 2250 upon 60. Just do it, just do it, just do this particular calculation. Just do this particular calculation. You will be getting the power that your vehicle took to create this, to move your vehicle by 1 kilometer. You can easily calculate it. You can easily calculate it. Okay, so if I say it is 240, I will be saying 40. Oh my god, 40 kilowatt. See what it is indicating? It is indicating that 40 kilowatt power is taken up to move the vehicle by 1 kilometer. To move the vehicle by 1 kilometer. Oh my god. Right? To move the vehicle by 1 kilometer. Now, when I say 1 liter of petrol is equivalent to 45,000 kilojoule of energy, my dear friends, what I meant by this is the power, this is the chemical energy that has been identified by humans, right? So we know this thing, this is the energy that my fuel is having, and every year we increase this particular thing. We increase the mileage of the vehicle, or in some special purpose vehicles you must have seen, we try to reduce the inertia. So where does the entire power go? Now you will see, in actual, if your vehicle is there, simply calculate it, my dear friends. And now my vehicle is moving forward. My vehicle is moving forward, and I say my vehicle is having the weight of 1000 kg. It is moving at a speed of 60 kmph. I have got a tire of 20 inches of size, and I can calculate the RPM of my tire, the rear wheel driven vehicle. Let's not talk about any weight transfer or anything else in here. And say the inertia between the road and the tire in the dynamic condition is 0.04. Okay, kinetic rotational inertia. Okay, I have just considered it. You will be surprised to know, you will be surprised to know, to move the vehicle by 1 kilometer, by 1 kilometer you merely require 100, or say for example 200 watt of energy. 200 watt of energy, that is all you require. Now when I say this thing, my dear friends, when I say this thing, I am not considering any kind of inertia. I'm not considering the rotational inertia of tires. I'm not considering the rotational inertia of all the rotating components inside my engine, or the moving components inside my engine. I'm not considering the rotational inertia of my gearbox, my clutch, my shaft, My wheel assembly, I'm not talking about anything in here. It requires just 100 to 200 watt of energy to move the vehicle. If I talk about a bus, you will find out to move the vehicle by 1 kilometer, it actually requires only 700 watt, or say for example only 1.2 kilowatt of energy or 1.5 kilowatt of energy. But chemically, how much energy is being produced? So what we usually do, the power produced by the engine output or the power available at the tire output, we calculate it from this particular source. Okay, in comparison to power required as per the normal calculation. Power required to move this vehicle at a certain speed till a certain to a certain distance, this is how we calculate it. Where does the maximum energy go? I know in 1 second if my vehicle is moving at 60 kmph, my fuel is having 40 kilowatt of energy, 40 kilowatt of power. But where does it go? At the output, I am receiving only 100 watt. Where does the entire energy go? It wastes out in the form of heat. When fuel burns, heating happens. It burns out in the form of pollutants. It's not just the energy. I burn the 100 gram of fuel, more than 50 gram of vapors of carbon dioxide, carbon monoxide, sulfur dioxide, many other gases also move out. So the complete fuel cannot be burnt. I cannot burn CO2. I cannot burn O2. I cannot burn sulfur dioxide and all the other pollutants that move out. It means in actual, more than 70% of this particular energy being produced by the chemical is not utilized. Is not utilized. Okay, so if for example I've only utilized 1 kilowatt out of it, and when I do it, what you are having, see, you are having the combustion chamber, you are having the air, you are having the fuel mixed inside it. Are you sure that you are going to burn the 100% of fuel? No. Say for example you burned 60% of fuel. When you burnt it, have you burnt it effectively to get this particular power? Some of the fuel is going to be burnt into this direction, the gases are moving here, gases are moving there, the flames is going here, flame is going there. It is not concentrated in a single direction, even if I do this thing. Okay, now majority of this particular fuel is moved out in the form of combustion pollutants. Now, when it happened, it requires a medium, and to do this thing, it becomes literally impossible for us to create a process in which the chemical energy is converted into kinetic energy without the involvement of heat. So it means even the heat is getting out, which is not of any use, for us. So some of the energy is wasted out in the form of pollutants, some of the energy is wasted out in the form of heat, some of the energy is wasted out in the form of unburnt hydrocarbons or unburnt fuel. Some of the energy is burnt out in the form of is lost out in the form of say for example non-useful directional movement of the flames, and some of the energy is going to be lost out in the form of inertia, because the piston is moving up, piston is moving down, even if piston is having certain weight. Now your piston is also attached with the crankshaft, your camshaft is also moving, is going to be attached with the flywheel, then it is going to be attached with the clutch wheel, it is going to be attached with the transmission shaft, differential shaft, your wheel assembly, everything is having the weight. It also needs to encounter the weight of all the rotating and the moving components inside the vehicle. And at the end, my dear friends, you will find out not even 10% of the chemical energy is being available at the tire. Not even the 10%. Okay? Not even the 10% of it is available at the tire. Okay, I hope you got this thing. So whenever we talk about the conversion of the chemical energy into kinetic energy, we never get the efficiency. We never get this particular efficiency to move the vehicle forward. So if I talk about the electric vehicles, how does these vehicles work? So before moving up with the electric vehicle, there is one more thing that I need to tell you. So I've just told you, power is the indicator to find out how much energy is being converted from one form to other form. Power is the indicator. And when I talk about the power, to understand the power, we also know there is force and there is velocity. Now, if I talk about the rotational word, I will be saying force is equal to torque and the velocity is equal to the rotational speed, that is RPM in here. Torque and RPM. Now, I am not talking about the 2 pi nt by 60, these kind of formulas. I hope you people already know these things. If not, just go with the indicators. Just understand about the indicators. Torque and RPM, torque and rotational speed. This is how we indicate power. This is how we calculate power. So whenever anything happens, whenever the energy is converted from one form to another form, you will find out there is going to be change in the space dimension, there is going to be change in the disturbance in the time dimension. Okay, everything is happening, everything is changing. So when these things happen, when these things happens, now you will find out it will produce certain torque, that is push or pull in the rotational world, and this push and pull will carry certain velocity. So say for example, I have got two combustion chambers. I have got two engines, engine 1 and engine 2. Now in the engine 1, I have got 100 cc capacity. Here also I have got the 100 cc capacity, 100 centimeter cube, cubic centimeter. Now see, in this particular cylinder, this is the bore, is 5 centimeter square, and this is the stroke length, that is 20 centimeter. Okay, and now see, this is another cylinder where this is the bore, say it is 10 centimeter square, and this is the say this is 10 centimeter. Okay, now in both of them, say for example, in both of these cylinders, 1 milliliter of fuel. My dear friends, I'm really sorry, I made a mistake in the calculation earlier. I have not made any calculation mistake earlier. Okay, 1 milliliter of fuel is burnt in 1 second. Here, the same thing happened. 1 milliliter of fuel is burnt in 1 second. Now, what is happening? The energy is getting converted from one form to other form. There is the creation of power. If the power is being created, we have generated power. Which particular engine, say for example, both of these engines have got the same power because the same amount of fuel is being burnt. But power is further indicated by torque and RPM. Which particular engine is having more torque and which particular engine is having more torque? Could you people please tell me this thing? Could you people please tell me this one particular thing? Which particular engine is having more torque and which particular engine is having more RPM? Anyone? In the chat box, please give me the response. Now, you will find out that the engine with the more bore, with the higher bore, will be having high torque. And engine with the more travel will be having high RPM, high velocity. Okay, this is how you will find out. So this is the basic difference that you will find out between these engines. Though the same count of fuel is being burnt, everything is happening, but the process how it is happening is different. Why this thing happened, we will be discussing about this thing in some other session. Here we need to move towards the electrical side at first. Electrical side at first. So we just understood this thing. To create the power, there is the requirement of torque, there is the requirement of RPM. We need to have these indicators. Now the same thing happens with the electrical systems. In the electrical system, we have got the electric motor, or you can also call it the traction motor. This traction motor is responsible to generate the power to move the vehicle forward. We have got the traction motor to move the vehicle forward. Okay, so we have got the traction motor to move the vehicle forward. Okay, we got this thing. We have got the traction motor to move the vehicle forward. But how does this thing happen? So how does electrical system actually work? How does electrical motor actually work? So for that, we need to go to a bit of basics. Now, why I said this particular session is important, now you will get to know about the most fundamental things about electrical systems. So whenever we talk about electrical systems, I've talked about the most basic unit of existence. So even for the electrical wire, see, this is the electrical wire. So this is just a conductor as of now. We all know everything is made up with the bundles of energy, and these bundles of energy forms atoms. And now these atoms, if they've got any free electrons in the outer shell, any free electrons in the outer shell, and when all these things are combined together, there is a material which has got the atoms which has the free electrons in the outer shell. We call it the conductor. Okay, we call it the conductor. Why? Because these particular electrons from one particular atom to other atom can move from its position to the other position. Okay, this is how they can move. If they've got a very small count of band gap between them, energy gap between them, these free electrons can move from here to there, here to there. That's why we call them the conductor. Any particular material in which these atoms can freely move forward are regarded as the conductor. But there is a thing. Nothing in this world is a conductor in its free form. There must be certain things, but we do not know as of now. But if we provide certain conditions to this particular conductor, the electrons are going to be aligned in the same direction, and when you touch it, you will feel the current. Oh my God, something is happening in my body. You feel it. So we need to provide certain push, and we call it the electrical push. Electrical push is regarded as the voltage. What is power? Power is equal to delta E by delta T is the indicator of energy, indicator of conversion of energy, which is, and the power is the indicator, and force and velocity is the indicator of power. Force and velocity is the indicator of power. Force is push or pull. In the electrical system, your voltage is the push and pull, while your velocity is the current. Velocity is current. What is velocity? Velocity, anything is changing its time. Okay, time is changing. Okay, from one place to other place, how much time it took. Okay, similarly, when I talk about the current, what do you mean by current and what do you mean by voltage? Let us just try to understand this thing. Voltage is the push. So I have got the electrical conductor available with me. So what I need to do, I need to create the electric field. I need to create certain moving magnetic field. When I create a moving magnetic field, or the interfering magnetic field, it creates the electrical field. Whenever I create the electrical field, what happens? All the electrons that this particular atom is carrying, they align themselves in the same direction. Now, I've already said this thing, all these electrons are in free form. So it means these electrons are already moving. These electrons are already moving inside the conductor. When I say conductor, they do not move out. They remain with each other. But the only thing is, as soon as it finds certain gap, it go. So this is the, say for example, these are the two atoms. This is the space between them. So this is the free electron, this is the free electron. Now this free electron will move here, this free electron will move there. They collide, they go back. They collide, they go back. They're already moving, they're already moving. But when I create this directed magnetic field, all these electrons align the same direction. All these electrons are aligned in the same direction, and the alignment of these electrons in the same direction, and now these electrons are free form. So this electron will try moving here and will try moving back forth, back forth, back forth, back forth, back forth. And now you must have noticed this thing. Go to any electrical wire that is carrying the current, go near to it, you will see a certain sound that is coming up. What this sound is? We call it the electrical sound. This wire is having the current. You can listen to the sound. What this sound is? Because electrons are moving. They're colliding with each other. That vibration you can listen. That particular volume, that particular noise you can listen, right? And as soon as you switch off the current, you will find there is no noise. There is no noise. Okay, so it means these are the electrons that are moving forth, back. How they move? How they move forward? When I pushed them. When I pushed them. How I pushed them, my dear friends? With the help of voltage, potential difference. Potential difference. And when they move forward, they're having certain velocity. Now, we do not call it velocity in the case of electrical system. We call it current. We call it current. Okay, let me just develop the analogy. So you have got a pipe, and this pipe is having certain water. water is moving down. So now you can say how much water is moving down per second. How much water is moving down per second? Per second, 1 liter of water is moving out. This is known as current. What is the current of water? Okay, okay, got it? 1 liter of water. But now, if I say there is something beneath it and it touched it is hitting it, it is hitting it. So there is a floor, it is hitting it. Okay, it is hitting it. With what force it is hitting it is the voltage. Is the voltage. Okay, now look here again, my dear friends. Let me just explain you this thing. Current. How do you measure current? In the form of ampere. What is ampere? Ampere means when 1 coulomb of charge is generated in 1 second, we call it 1 ampere. What do you mean by 1 coulomb of charge? It means 6 point something into 10 raised to power 31 electrons when aligned in the same direction, when this particular count of electrons are aligned in the same direction, see, moving forward, rearward, forward, rearward, forward, rearward, in a single second, we call it 1 ampere of current. Okay, when one, sorry, not in single second, I'm really sorry. When 1 coulomb of charge is moving forward and backward, we call it 1 ampere. We call it 1 ampere. So say for example, this is the wire. This is the wire having the cross section of 5 millimeters square. These are the electrons. We call something good conductor, bad conductor, different type of wires. So that are all dependent on the resistance that your wire produces. Okay, we call it like not just the good conductor and bad conductor. We also say for 100-watt power supply, you need this thick wire. For 1000-watt power supply, you require a very thick wire. For 10,000-watt power supply, you require a very, very thick wire. How do you calculate it? How many electrons are aligned in the same direction? Okay, say for example, wire thickness is only 5 millimeters square and I am generating 100 coulomb, 100 ampere of current. Also 1000 ampere of current. So many electrons are trying to move out at the same time. At the same time, what will happen? The tire will, sorry, your wire will burst. It will burst. Or if I apply a very high voltage, I'm just pushing it, creating the magnetic field. So magnetic field will try to push these many ampere of current, these many ampere of current moving forward, to move forward, to move forward. Okay, first you need the conductor which has got these many count of ampere, these many count of electrons available at a cross section. Please remember this one thing, at a cross section first these many electrons should have to be present. So 1 mm of wire maybe does not have sufficient electrons to create 1 ampere of current. So to create 100 ampere of current. But 2 mm square of cross section might have it. Okay. But a 2 mm square of wire can create 50 ampere of current, 100 ampere of current. But it cannot create 150 ampere of current. Do you know why? Because it does not have these many free electrons. Okay, and this is the limit, the maximum push that I can generate. If I increase the push, the number of electrons will also increase, which is not possible. Which is not possible. So this is how the entire analogy of electrical system works. So we have got the electrical motor. There are many kind of electrical motors. We primarily say there are 7 different kind of electrical motors. There are many different kind of electrical motors. Say for example, brushed DC motors, brushless DC motors, PMSM motors, AC induction motors. We have got switched reluctance motors. We have got synchronous reluctance motors. We have got axial flux motors. We have got different kind of motors. Every motor has got the same working principle, but how they are set up, how they create the energy, how they create the power is bit different. Now there is a thing. If you are having the engine, in this particular engine, sorry, IC engine, in this particular IC engine, you can burn 1 milliliter of petrol at max in 1 second. You know how much heat will be produced. Okay, an engine would be able to sustain this particular heat. Fine. In the case of electrical motors, you have got the wires connected. So you have got a stator, you have got a rotor. Okay, so you have got two primary things. You have got a motor stator. A stator is made up of wired coils. Okay, wired coils. Now inside this particular coil, I have got one particular shaft. This is the shaft. Now this shaft is rotating and it is responsible to rotate your tires as well. Okay. Now this is the coil. These are the coils or the permanent magnets, whatever you want to have. Now you will see this is the coil. I pass on the current. In this coil I have got, in this particular system I have got these wires. So I have passed on the current to it. As soon as I created the current, I passed on the current to it. What happens? This particular current will create the magnetic field. It will create a magnetic field. Okay, now we know this thing, every magnetic field has got positive or negative. Either it will attract positives, like positive opposite attract, or the similar repel. Okay, when I say positive negative, it means the different poles, north pole and south pole. Okay, it will be having different opposite polarities. So now what happens, I passed on the current. Now when I passed on the current, it created the magnetic flux, the same done by the other side of a stator or all the sides of a stator. Now I am having this particular shaft inside it. This is the conductor. I also passed on the current to this particular conductor. When I passed on the current to this particular conductor, now these are two stators that are having their own magnetic field. Now I have got the stator, I have got the rotor here, which is creating its own magnetic field. Now we know this thing, this rotor is having certain positive, certain polarity, say P1 polarity and P2 polarity. Here it is having P1 polarity, here it is having P2 polarity, this side is having P2 polarity. Now P1 will try to move towards P2. So what will happen? It will move. So now you must have seen this thing, there is a magnet having polarity P1. There is a big magnet having the polarity P2. Now opposite, both are opposite. So P1 will try to move towards P2. It moves towards P2, right? This is how it usually works. Now if I use a bigger magnet, what happens? It moves faster. I use a very big magnet, what happens? It moves very fast. I use a very small magnet, then it moves slowly, but it will move there. Okay, so same thing happens. Your particular rotor will start moving into this direction and then into this. It will start rotating. Higher the current that is being provided here, higher is the magnetic field. You will find out greater is the velocity. So as I increase the current, what happens? RPM increases. How it increases? I've just told you this one particular thing. Now we all know this thing. 1 ml of fuel can be burnt just in 1 second. This is the maximum. So I've got power. Okay. In the power, I've got the force and velocity. Okay, power is fixed. Per second, or you can say per second, I can only convert certain energy from one form to other form. I can say the power will remain constant, that is 1 kilowatt, but my velocity and load capacity will change. My voltage and current will change. So when I increase the current, the voltage will drop and the power will remain same. When I increase the voltage, the RPM will increase. Sorry, the load capacity will increase, but the RPM will reduce. So you must have noticed this thing. When you've got high load, the velocity reduces. When you've got less load, the velocity increases because the minimum and maximum power is already fixed. So this is how the electrical system usually works. Now, my dear friends, you will find out the motor that you are having. I provided certain electrical current. I provided, say for example, I have got the wire. My wire is also having certain resistance. So I provided the wire. I have the wire and I provided 100 watt of power to my wire. Now this particular wire is connected to my motor. At the output, At the output, if I need to measure, I provided 100 watt of power to my wire. At the output, I will find out that 90 watt of power is available. The rest 10% will move as the losses because you have got the rotational inertia. Your rotor is rotating, right? Rotation inertia. And your wires, even the wires, you have got certain resistance. But what you will find out 90% efficiency, 92%, 95% efficiency. In the IC engine, what was the efficiency? Very, 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 very low. So directly if I need to compare, I will find out electrical vehicles are much better in comparison to combustion vehicles. Could you people please confirm in the chat box that you got this particular clarity? I believe this is the most fundamental, the best effective way to understand the difference between these things, the electrical vehicles and the combustion vehicles. Could you people please confirm if you got this particular concept? If you got it, please go for the thumbs up, go for the hearts in the chat box, or write down just you got to understand this particular topic. Now I will be moving specifically towards our discussion. Now if you will be using the electric vehicles, electrical powertrain, if you will be using the electrical powertrain, my dear friends, please make me understand that you got this particular concept. If you will be using the electrical powertrain, you will find out, my dear friends, there are many changes that actually incur, that are actually there between the differences between the electrical vehicle and the combustion vehicle. What these differences are: the number of rotating parts, number of moving parts. In electric vehicle is much less in comparison to combustion vehicle. Now you see what usually happens in combustion vehicles. In combustion vehicles, you have got engine. Now inside the engine, see, in your motor, what did you say? For example, engine and motor. In an engine, let me just do it like ways. You have got the engine and you have got the electrical motor. Rotating components, rotating slash moving components. First is piston, second is crankshaft, third is your camshaft is also moving, right? Then your flywheel. Here, only one part, that is rotor. That's it. That is going to have a very less weight in comparison to flywheel, camshaft, crankshaft, and piston. Just not even 10% of the total weight of these items together. Okay, now see, heat loss in comparison to IC engine. So in IC engine, inside the cylinder, we have got almost 1000 cc, 1000 degrees Celsius of temperature. At the engine base, you can measure about 100 degrees Celsius. You are using everything to reduce the temperature. So temperature loss is very high. Compared to this, not even 10%. Compared to IC engine, not even 10%. Okay. Then, what else can I say? Other moving parts, moving or rotating parts. It is mandatory to have clutch, gearbox, and other transmission elements. Now here, it is not mandatory to have gearbox. Yes, this is the beauty of the electrical system, electrical motor, that you can create very high torque, very high power without even using the gearbox or clutch. Clutch, not required. Differential, differential is required in both the cases. Gearbox is either not required or the size is going to be very less. So partially required or not required. Other transmission system is required. So you can see the rotational inertia of electrical motor system is much less in comparison to IC engine. To control the speed, to control the power, you have got the gearbox in IC engine based vehicles. But here you have got the motor controller. The weight of motor controller is 10% of the weight of gearbox with no rotating components or moving components. Clutch is not at all required. is not at all required. So this is the basic difference that you will find out. Now in the case of electric vehicles, in the case of electric Baja Buggy, you will be having motor, and to find out what speed is required, you're not going to have the gearbox to shift the gears and everything. You need to fluctuate between the voltage. When you need more torque, you will be increasing the voltage. When you need more speed, you will be increasing the current. And each of these things is going to be automatically regulated with the help of controller. Motor, controller. Now you will be having the battery. Now you are having the high voltage battery. High voltage battery. Now in the case of our vehicle, conventional electric, conventional IC engine based vehicle, you've got everything available with you. You've got the engine, you have got the petrol. With the petrol, you've got the alternator. This alternator is going to create the 12 volt of supply. This alternator will also create the 12 volt of supply, which will charge a 12 volt battery, which will run everything in your vehicle. Say for example, your air conditioner, all the lights, horn, your music system, everything in your vehicle is going to be regulated by the low voltage supply. In this particular case, you will be having one high voltage battery. With that, to maintain your battery is the combination of cells. Generally nowadays nobody is using the lead acid batteries. You will be using the lithium ion cell batteries or some other kind of chemistry. Now these cells are very fragile and very volatile. Okay. How is power created? Power is created by the discharge of these cells, the discharge rate of this cell. Now each cell is having, say for example, 3.7 volt. Each cell is having 3.7 volt, and I need to discharge it completely. Now as I discharge it, even this particular cell is going to be heated. When it heated, there are high chances it will heat the entire system and can burst the battery. So when I do this thing, I will be doing it in a way that this solid cell is not going to be discharged completely. I require 10 volt of power, 10 voltage at the output. 10 voltage is the output. So what I did, I took 0.5 volt from this cell. I took 0.5 volt from this cell. I took 0.5 from this, 0.5 from some, 0.5 from some. And as I took 0.5 from some, I found out that the temperature of this particular cell increased, which is now at the dangerous zone. So next time when this particular 10 volt is required, I won't be taking the voltage out of it. I will be taking the voltage out of this. So now this particular synchronization that is needed to be developed is being developed with the help of battery management system, which decides that if you need to charge the cell, how do you charge it? This particular cell is charged by 10%, the other is charged by 15%, the other is charged by 30%, and it tries to balance so that at the end of the day, your target is to safeguard your battery, safeguard the life of the battery, increase the life of the battery. And at the same state of discharge, how do you discharge it? No particular cell is going to be discharged at a one time. Okay, there should be a balance that is needed to be made up in the entire circuit of cells. This is how it works. This is how the entire battery management system works. There are many other things. There are 11 points of battery management system on which it works. A state of charge, a state of temperature, state of discharge. Then you need to look up into the temperature. You need to look up into many other factors. Cell balancing, everything is need to be done. So with the battery, to get the output or even to provide the input to the battery, you require the BMS. Now after that, you will be having DC to DC converter. Now your battery is generating the DC current. The battery is generating the DC current. Now the high voltage system from 96 volt, 384 volt, 48 volts, you need to create a 12 volts to run the other supply. For that you will be having the DC to DC converter, high voltage DC to low voltage DC. You will be having this particular kind of system. Okay, so now first how will you make the arrangement? You will be having the motor. To move the motor, this motor is going to be connected with the controller. Your controller is connected with the help of BMS, which is connected with the battery. Okay, now your controller is connected with the pedal or traction system. If you require more velocity, if you require more torque, controller will decide. When the controller decides, okay, how much torque is required, it will draw, see this is the BMS, it will draw more voltage from it and supply more voltage. Okay, sorry, yeah, it will supply more voltage here. If you require more speed, it will draw more current, it will supply more current. If you want to reduce it, it will fluctuate all these things in a fraction of seconds. Controllers are generally made up of MOSFET, and there are many other mechanisms by which we make the controllers to increase this particular lag time. Now this BMS is also connected with the, or this controller, this BMS, this entire system is also connected with the DC to DC converter to run everything else. Even your throttle that is connected with the controller is need to be connected with the DC-DC converter. Okay, so this is how the entire system in the electric vehicle works. So even for your Baja Buggy, you need to make the same kind of mechanism. Generally, you will find out the teams which used to participate in such kind of events use PMSM motors. Do you know why? There are all kind of motors: BLDC motors, PMDC motors, synchronous motors, PMSM motors, induction motors. Why do teams prefer to go with the PMSM motors? You will find out each of these motors have got certain advantage, certain disadvantage. Even the brushed motors, they have got certain advantage and disadvantage. DC motors have brushed motors have got very good torque, output torque, initial torque, but people prefer to go with the BLDC motors because they got very less wear and tear. Hmm. At the same time, you will find out there is a PMSM motor. You will find out the initial torque of the PMSM motor is much less in comparison to PMDC or BLDC, but people prefer to go with the PMSM motor. Do you know why? Because the peak torque or the peak power produced by PMSM motor, the time frame for which the peak power can be generated. So I've told you, when you increase the power, the voltage inside the coils of your motor will also increase, which will heat the winding. If the winding is going to be heated up, there are high chances it will get burnt down. Okay, so we need to regulate the entire system. How do we regulate it? We regulate it with the help of your motor controller. Okay, so in PMSM motors, the system has been made in a way that in the PLDC motor, if I say the peak power can be achieved for say 5 seconds. In the PMSM motor, I can have the peak power for 15 seconds. The adaptability of the system to have peak power, the time frame for which I can have the peak power in the PMSM motors is greater in comparison to other BLDC type of motors. That's why teams are preferring to go with the PMSM motors, but it will provide the peak power for a longer time frame. For a longer time frame, longevity of peak power in this PMSM motor is good. If you look up into Tesla, you will find out Tesla is using AC induction motor. If you look up into Toyota Prius, you will find out they are preferring to use the BLDC motor. Okay, so each of these motors have got certain advantage, certain disadvantage. Nowadays, SRM motors, switched reluctance motors, and synchronous reluctance motors, and even asynchronous reluctance motors are getting very popularized. Nowadays. I hope you people got the clarity on how this entire electrical system in the vehicles work. If you got the clarity, could you people please confirm me if you got to know about this entire thing? Could you people please confirm in the chat box? If you have not subscribed us yet, I would request you people to please give us a subscribe. It will help us out in reaching out to more people. Please subscribe our channel. We will be coming up with many short videos, the complete course on electric vehicle, complete course on automobile engineering, complete course on motorsports engineering, complete course on all the possible type of motorsports event and the technology, engineering technologies. Okay, we will be coming up with all these things in future. So please give us a subscribe. So thank you so much everyone. Let's move forward. Whenever you participate in any kind of history and motorsports event, your entire intent is to win the championship. I've discussed about this entire thing in detail in the last session. Okay, I've discussed about the entire thing in detail. So I want you people to please have a check on the discussion that we have made in the last lecture. Now, as each one of you know this thing, this is a free certification session. So my dear friends, I will be sharing the Google form where you people are required to mark your attendance. You people are required to mark your attendance. I request each one of you to please mark your attendance. I will be sharing the attendance form link with you people just in a minute. Just in a minute, I will be sharing this particular thing with you. Okay. I have shared the attendance form with each one of you. If you want to receive the certificate of participation for today's webinar, I would request you people to please uh, fill this particular form and mark your attendance. Please fill this particular form and mark your attendance. I have shared the Google form link with each one of you. I would request you people to please mark your attendance. You have got 5 minutes of time to mark your attendance here. I would request you people to please mark your attendance in the attendance form. I have shared the attendance form link with you people. Please mark your attendance. The students who will be marking their attendance will be getting the certificate of participation in today's webinar. So I would request you people to please mark your attendance. In the next 5 minutes, I will be not accepting any responses in the attendance sheet. So please do it now. Okay, keep on filling the attendance form. If you have not subscribed us yet, I would request you people to please subscribe us. It will help us out in reaching out to more people. You can also find us on Instagram. Please give us a follow on our Instagram handle as well. You can visit our website and find out these courses. We have got 30 days exclusive program, 30 days internship come training programs, 4 weeks internship come training programs, where you will be getting to know about each and everything associated with these particular topics. So anyone who is going to join our internship come training program, they will be receiving 3 different certificates. First, you will be getting the certificate of attending this particular internship come training program. That is a certificate of completion of the course training. Okay, then you will be getting the certificate of completing the entire internship with us. We will be giving you certain live project. So first, you will be getting the certificate of project completion. You will be getting the certificate of internship, and you will be getting the certificate of training with our company. 3 different certificates which will help you out in excelling your professional journey. This particular course, even if you choose the CI internship, CAD internship, automobile engineering internship, or the EV internship, comes up at a cost of just 3,500 rupees for 1 month. In this thing, we have got 4 modules. In each of these programs, we have got 4 modules. In the first module, we will be discussing about the fundamental of individual subjects, be it CAD, CAE, automobile, or EV. In the second week, we will be discussing about the advanced version of it. In the last week, you will be working on the project. In the third week, you will be working the teamwork. You're not just going to work alone. There is going to be the group of other students who will be joining you people in the entire internship program, and you can enhance your abilities to develop that particular structure. So I would recommend you people to please join this internship come training program. To know more about it, please drop me a message on this number. We will be sharing the complete details of this internship come training program with each one of you. Check our website athleteracingclub.com/internships to find out the details about these training programs, these internship come training programs. Every Monday, a new batch starts. Chitij, just drop a message on this number 8800219630 and Chitij will be connecting with you. Okay, just one more minute and then I will stop receiving the entries for attendance sheet. Attendance. Just one more minute. If you have not followed us on Instagram, I would request you people to please give us a follow on our Instagram handle. We are available with the name of ARC Global on Instagram. Our username is underscore ARC Global. Underscore ARC. Please find us on Instagram and give us a follow. You will get the complete updates of all the coming workshops that we will be coming up in future. On 26th of February, we are having the session on formula designing dynamics. Okay, formula prototype designing dynamics. So if you are a student team planning to build a formula vehicle, that particular session is a must attend for you people. Okay, so now I'm not going to accept any entry in attendance. So let's move forward with our topic of discussion. So if there is any student team which is planning to build a buggy or is planning to build a vehicle, or if you're an individual thinking to build a racing car, thinking to build an electric Baja Buggy, or thinking to participate in any kind of motorsports event, please make sure when you purchase any kind of electrical system, there are certain standards, certain ratings that are needed to be followed up. In India, if you are planning to launch an electric vehicle, there are two governing bodies, ARAI, ICAT, and even NATRIP these days have started their work. Or if you want to launch any kind of automobile in India, you need to take the license from these institutional bodies, either from ARAI or ICAT, and nowadays even NATRIP has started to provide the license for two-wheelers. I'm not sure if they provide the license for three-wheelers or four-wheelers or heavy vehicles or not. But ARA and ICAT provide the license for all the possible kind of vehicles in India. So if I want to launch a vehicle in India, I need to take the license. I need to take the homologation license, homologation approval from ARAI or ICAT. I need to take these things from these governing bodies. They perform certain tests on the vehicle and they do it. So even when I need to purchase a motor, I need to purchase a battery, a controller, I need to find out, are these motors and batteries AREI or ICAT approved? It means, are they safe to use in our vehicle? Because everyone nowadays has got the issue, if we are going to build an electric vehicle, there are high chances it can burn. Okay, or if I'm using the motor, there are high chances that it will get damaged if I move my vehicle in dirt, or if I move my vehicle in, say for example, in muddy patch, or in watery patch. Okay, in watery patch. So for that there are certain certifications. For everyone who is building the Baja Buggy, you need to take IP67 certificate. What do I mean by IP67? It means resistant to water at certain pressure for certain time. Resistant to dirt at certain pressure for certain time. So this is the IP67 rating that every individual should have to procure to launch the off-roading vehicle. So if you want to launch a car in India, you need to find out, you need to build a battery, you need to build a motor which is resistant to water, which is resistant to dirt. But what resistant to dirt and water? So I've simply made a battery. I have got all these cells. Okay, I've got all these cells. I've enclosed them in a container. And now I say, when I put it in air, when I put it in a normal room, I will just say one thing, in the normal room conditions, no dirt is entering inside my system. Wow. Can I call it IP67? Or even if I pour water over it, water is also not getting inside it. It is completely isolated. Can I call it IP67? No. It is resistant to water. It is resistant to dirt. It is resistant to water. It is resistant to dirt. But to what extent? If I increase the pressure of water, would it be able to resist it? Okay. If I increase the pressure of water, but I also make sure that the battery is inside, say for example, 100 meter inside the ocean, and okay, 100 meters inside the ocean, 10 meters inside the ocean, say for example, 50 meters inside the ocean, but only for 1 second, and I move it out, or only for 10 seconds, everything is fine. But if the battery is poured inside the water for 100 seconds, the water will start getting inside. It is still resistant against water at certain condition, but to a certain condition we call it the standards. To all these conditions we call it the standard. Resistant to dirt, to a certain pressure, to a certain condition. as justified by the India, justified by some international standards. We call it the ratings, IP65 rating. These are the international ratings. IP67 ratings. So just check the website of ICAT, check the website of ARAI, or check any general uh, regulatory body website. You will find out what do you mean by 6, what do you mean by 5, what do you mean by resistant to water in IP67, what do you mean by resistant to dirt in IP67. You will find out these particular standards there. So your motor, your controller, so it will be IP67 certified. So that at normal condition, when you drive a vehicle, any condition, the performance of the vehicle is not going to be interrupted, it is not going to be damaged. Moreover, your battery is not going to be damaged at any possible road condition. Okay, they should have to be IP67 certified. For the student teams, either you need to get your batteries and motors and all these things tested, or you can simply purchase the OEMs which are already approved by ARAI or by ICAT or by NITRIC. I'm not sure about NITRIC if they provide the certification or not, but at least ICAT and ARAI for OEMs. Or you can get the IP67 tests done. Okay, you need to find out the nearby laboratory which performs such kind of tests. Okay, I hope you got this particular concept. So for all the electrical Baha teams, for all the electrical teams, let me just tell you one thing. If you're making a Baha buggy, if you're making the off-roading buggy, you need to have a very high ground clearance. Now, there's a thing. For electrical vehicles, there is a disadvantage. I want to move my vehicle only for 20 kilometers. Okay. Now, there is a thing. I have got a complete vehicle available. Okay. I have a complete vehicle available. I only want to move my vehicle for 20 kilometers. For that, I can simply do this is my empty fuel tank. I can put on 1 liter of fuel. I can move it. Simple. My only intent is to move it for 20 kilometers. In the case of electrical vehicles, the entire housing system that I am going to develop for the electrical batteries, it carries certain weight. So the weight of electrical vehicles is, if I do not talk about the transmission system, if I just talk about this particular battery, I always need to carry this particular fuel system. I always need to carry this particular fuel system. I have just got an empty fuel tank. I am going to apply, I am going to fuel it with 1 liter, I can move my vehicle. But in the case of batteries, I always need to carry this particular load of battery to move the vehicle forward. Okay, so please remember this one particular point. Now you are going to carry this particular load at a certain height, which will increase your center of gravity. As the center of gravity increases, the stability of the vehicle at high speed cornering reduces. Reduces. Or the stability of the vehicle in the case of acceleration or deceleration also reduces. So this is one of the biggest challenge with the electric vehicles. Electrical Baha buggies, you need to find out the exact position for your batteries. You need to find out the exact position of your battery so that you do not increase the center of gravity height by way too much. See, for example, I have the fuel tank. This fuel tank is having the weight of 10 kg and I can fuel it by 5 liters. By 5 liters. And with 5 liters, I can move my vehicle by 75 kilometers. Now, to move the vehicle by 75 kilometers, I need to carry a battery which will be having 50 kg of weight. It is not justified at all. You need to increase this much of weight. So this is one of the biggest drawbacks with the electrical Baha buggies. But at the same time, everything else is going to be very good. So you will find out average weight of Baha buggies, student championship Baha buggies is 150 kg. But if I talk about the electrical Baha buggies, you will find out the weight is 200 kg. Just because of batteries. Okay, just because of batteries. Okay, okay, so everything else remains same. You need to select a very good motor. You need to find out the how much power you require to move the vehicle forward. You know what battery is required. I have just given you this particular hint. If your vehicle is having the weight of 1000 kg, you require 70 watt or 100 watt or 80 watt to move the vehicle by 1 kilometer. So similarly, if you need to find out the same thing for your Baha buggy, you can find out the exact thing. So for example, if I talk about the bikes, two-wheelers, you will find out to move the vehicle forward by 1 kilometer, you require only 30 watt or 40 watt of power to move the vehicle forward by 1 kilometer. So if I talk about the Baha buggies, You will find out you require not more than 70 watt, not more than 70 watt to move the vehicle forward by 1 kilometer, not more than 70 watt. Okay, it's going to be about 50 watts or 70 watts only to move the vehicle forward by 1 kilometer at a speed of 60 kmph. So this now you can do the entire calculation to find out what battery size is required to move the vehicle. Now I'm open to questions. If you people have got any question, please write down your question in the chat box. I will be looking up into the chat box for the next 2 minutes. If you've got any question, you can ask your questions. So thank you so much everyone for joining up with today's session. Next week on 26th, or next Monday on 26th, we will be coming up with a session on Formula vehicles. ARC Global has been working into this industry for the last 7.5 years. We have worked with the students of more than 1,000 engineering institutes in India. This is what I can say. We have trained more than 50,000 students in the field of student motor sports. We have collaborated with 100 plus events in the space in the time of last 7.5 years. And we have literally seen all the possible teams developing these kind of vehicles. We know what good these people are doing, what bad these people are doing. We have collaborated with international teams as well. So if you really want to learn about instant motorsports, if you want to develop a better vehicle, I would say just collaborate with us. Connect with us on Instagram, drop me a message on this particular number, and let's just try to build a better vehicle this year. If any of you have got any question, please ask your question in the chat box. Anyone, any question? No question, no question, no question. Thank you so much, Devesh. Thank you so much. I believe that you have already subscribed us. If you have not subscribed our YouTube channel, please do it. And if you like the content, I would also recommend you people to please share our YouTube channel with all your friends and make them subscribers. We are on a target to make every possible engineer know about the motorsports, to know about the automobile, to know about the technology. And this is why we are coming up with such sessions. If you want us to host a session for your institute, for your college team, or if you want us to come and visit your campus and take up a lecture on any particular kind of technology, just drop us a message on this particular number. We will schedule a session in your campus virtually or physically. So thank you so much everyone for joining in. With this, I believe I need to take a leave from today's session. So thank you so much everyone.